All right, let's start. So solving trig equations. We've already been doing a lot of these. You already have a lot of experience with the cosines, with the inverse cosines. So here it is. It's written in nice and neat. So if you're in degrees, I probably should have put like lines on them or something maybe. So if you're in degrees, I guess I can call this x1 and this one x2. So there's always two equations. And so this is x1 and x2. So there's always two equations for sine and cosine. Now for cosine, I know you're probably saying like, Chavez, I don't see two equations for cosine. Well, there is. It's just that the plus is one of them and then the minus is the second one. See? So, and we'll talk about where the plus minus comes from. I mean, hopefully by now we already have an idea, but if you don't worry, we'll talk about where it comes from. And then for 10, there's just one, and we'll talk about it. We'll talk about where it comes from, guys. So I gave you guys some little notes there, verbally and graphically and all that good stuff. And then where n represents an integer. So n is just like how many cycles have you done? So 360 is one revolution, 2 pi is one revolution. So there's the difference. That's where you see the 360n. All these formulas, all of them can be derived logically. Yeah, so let's talk about a little bit about how we derive them, guys. So the whole first page is notes. So look, we did nothing. The whole first page is notes. So always refer to the first page when doing questions like this. So here we go. I'm going to go ahead. I'm probably going to need the whole space. So I'm going to start over here. I'm going to start with sine. So if I give you a problem like sine of what angle equals a half, where I want all the angles between 0 and 2 pi. So let's do the radians one first. You would tell me, well, sine is a half in quadrant 1 and in quadrant 2. In quadrant 1, you have this coordinate. And in quadrant 2, you have this coordinate, negative square root of 3 over 2, and then a half. And then remember, we said that sine was equivalent to your y value. So we know that the two answers are pi over 6 and 5 pi over 6. But why? All right, let me tell you why. If you were to solve for theta, and I'm going to type theta 1, if you were to go inverse sine of a half, or you can say the word arc and then plus 2 pi n. So this that I have in green, the calculator will always spit out the pi over 6. Calculator will always, now if you have a super fancy CAS, it might give you the 5 pi over 6. But calculator will always spit out x equals pi over 6 for this, or theta equals pi over 6 for arc sine of half. So if you type this command, you're going to get pi over 6. If you open up something called Maple and type arc sine of 0.5, it's going to say pi over 6. If you open up MATLAB, another CAS, and you type that in, it's going to give you pi over 6. I know because I tested it out earlier. If you go to Desmos and you type arc sine of 0.5, it's going to give you pi over 6 in decimal. If you're in degree mode, it's going to give you 30 degrees. So there it is. So that's how we get our first one, pi over 6 plus 2 pi n. Now, how do we get the second one? How do we get the 5 pi over 6? Well, here's how this formula came to be, guys. This formula right here. It took advantage of the fact that the distance from, and look at this in blue, the distance from here to there, that's a pi. And then it said, well, this reference angle here in green, that reference angle in green, that's just pi over 6. So if I go pi minus pi over 6, it's 5 pi over 6. And we know that we've been doing that for a long time. So that's why we say that equation 2 is pi minus arc sine of your argument, in this case a half, plus 2 pi n. And we know that arc sine a half is going to spit out again pi over 6. And then just common denominator, put a 6 there, put a 6 down there. And then 6 pi minus pi, that's just 5 pi over 6. And then we call these general equations, guys. So that's a general equation, and that's a general equation. We call these general equations. And from there, we can get all of our answers. Does that make sense, guys? Guys, help me out here, guys.
Yes.
Okay. Cool. Oh, for common denominator. You know what I mean? But you know where the pi came from, right? Okay. So yeah, that's where they got the formula, guys. So from now on, we can always just do that. Of course, if it's a perfect coordinate, I wouldn't even bother. I would still do it with logic. I guess let's talk about the arc cosine real quick. I don't think I really need to, but we'll chat about it really fast. Do we have any questions before I proceed, guys?
So when it asks you to find, okay, so that's the general equation, right? But when do we know when to do like only, what's the word? Like the positive ones, or that doesn't make sense. Like when do we know when to do like pi over 6 and then 5 pi over 6 and 7 pi over 6 and 11 pi over 6? You know what I mean?
Oh, when they
Like-
tell you like find me all the angles between, look at this answer right here. You see this restricted domain between 0 and 2 pi that I circled in black? So I want all the answers between 0 and 2 pi. Well, pi over 6 is one of them. So I would just write theta equals pi over 6, comma, and then what's the next one? Well, the next one is this one, 5 pi over 6, and then that's it, because if I add 2 pi, I'm be outside the domain. If I add 2 pi, I'm outside the domain. But if I were to put 4 pi, so here I am, I'm changing it to 4 pi. So then I'm going to add 2 pi to it. So here we go. I'm going to do a common denominator. So I'm going to turn that into a 6. So that means I multiply by 6. So I'm going to turn that into 12. 12 divided by 6 is 2 pi. 12 plus 1 is 13. So 13 pi is another one. 13 pi over 6. And then again, what did I do? I turned this into 12 pi over 6 to add them up. And then 12 plus 5, what's that? 17? 17 pi over 6. And there's another one. So that is all my answers between 0 and 4 pi. See, did I answer your question, miss?
Yes.
Okay. All right. Now for cosine, I have a little bit of space there, and I don't want to take it. I don't want to use that space for cosine, so I'm gonna put it in here. So here's cosine, guys. Here's my unit circle, and I guess I'll do the same one since we already kept talking about pi over 6. So if I were to write, give me all the answers. So I'm gonna write theta, all the answers between 0 and 2 pi, where cosine of that angle is equal to square root of 3 over 2. So if you were to write that, we know those answers. Those answers are in these two rays. So, and hopefully you guys agree that this angle right here, that's pi over 6. But look, if you count clockwise, this is also negative pi. The reference angle is pi over 6 there. So that is negative pi over 6 if I go clockwise. So that's where the plus and minus came from, guys. This is where the plus and minus came from. Now check it out. I'm going to go ahead and write theta 1, theta 2. Well, I guess for now I'll just write theta, and then I'll write theta 1, theta 2. So theta equals plus minus arc cosine of square root of 3 over 2 plus 2 pi n. So now I'm going to write theta 1, theta 2. The calculator will only spit out one answer for this. So I'm going to write it here. Calculator will only spit out, let's see, what was pi over 6 when entering arc cosine of square root of 3 over 2. And I'm sorry that I'm writing all over these super awesome notes here. So when I type in this expression into the calculator, it's only going to give me pi over 6. But we know there's more than that answer, guys. What about 11 pi over 6? So here's how we do it. So theta, I'm still just writing theta. I'm not going to write theta 1, theta 2 until I break it up. Plus minus pi over 6, which is what the calculator spits out if you're in radian mode. If you have a CAS, it'll say pi. If you have a regular calculator, it'll give it to you in decimal. If you have a degrees, then it'll say 30 degrees. So theta 1, the positive one, pi over 6 plus 2 pi n. That's going to give you all the answers in quadrant 1, all of them. Theta 2, well, the other angle is in quadrant 4. So how do I get the one in quadrant 4? Well, negative pi over 6 is in quadrant 4, And if I do a whole revolution, it will give me all the answers in quadrant 4. So remember how I said I want all the answers between 0 and 2 pi? So here are my answers, guys. Theta equals, one answer is pi over 6. How do I get the other one? From theta 2. Take the negative pi over 6, and I'm going to erase this right here so I can use this little white space. And I'm going to add 2 pi. Common denominator. Put a 6 in the bottom, put a 12 on the top. 12 divided by 6 is 2 pi. Negative 12 plus a negative 1, that is a positive 11. There it is, 11 pi over 6. And you and I both know that 11 pi over 6 is an answer because it's a perfect coordinate. See? So it works. So that's where the plus minus comes from, guys. Cool? Or not cool, guys?
Cool.
Okay, cool. All right, last but definitely not least, the tan. So let's just work on this one. Tan theta equals 1. And again, I want all answers between 0 and 2 pi. So for tangent's one of the easiest ones, guys. You just have one equation because, well, why? Because look, this is the only location, the only time that your magnitudes for x and y are the same. And that happens at pi over 4. Now I want you to notice it also happens in quadrant 3. The magnitudes are also the same. I said the only time last time, right? So that was a wrong statement. Only in quadrant 1 and quadrant 3, in those two specific locations, are my magnitudes for x and y the same. Well, okay, I said the word magnitude, so now I'm saying a whole bunch of wrong statements. Magnitude means the sign regardless of positive or negative, and all the 1s over 4s, the magnitudes are the same. So 3 pi over 4, 5 pi over 4, 7 pi over 4. This is the only time that your ratio, y divided by x, that's what tan is y divided by x, or sine divided by cosine, will give you an output of 1. See, square root of 2 over 2 divided by square root of 2 over 2, that's 1. Negative square root of 2 over 2 divided by negative square root of 2 over 2, the negatives cancel out, and that's 1 again. So these are my two answers. I want you to observe that this right here, what is that line in black? Is that a nice linear line? So that's where the pi n comes from, guys. So let me go ahead and write that statement down. So from here, you can just go theta equals arctan. You can also say tan, the inverse tan of 1 plus pi n. And that will give you all your answers where n is an integer. So the calculator will spit out pi over 4 or 45 degrees if you're in degree mode. And then if you just keep adding pi to it, you'll get all your answers. So now that I wrote that, and there's no reason to write theta 1, theta 2, because there is no two thetas, it's just one equation. So here are all my thetas. This is your general solution. And then theta equals pi over 4, comma, and then I need a common denominator, so 4 and a 4. So 4 plus 1, that's a 5. 5 pi over 4. And there it is. Those are my two solutions between 0 and 2 pi. So do you guys see how they came up with this equation for arctan? Virtual class?
Yes.
Okay. So, and what's the difference between radians and degrees? Not really much, guys. Hopefully everyone now knows that 180 degrees is the same thing as pi. So it's the same thing with over here, guys. 2 pi is the same thing as 360 degrees. So yeah, that's where those numbers come from. All right, let's put this into practice and see what's up. So let's go to this example here. And it says, solve the equation 10 sine x minus 0.2 equals -3 algebraically. That means I want to see it in the domain 0 to 4 pi. Verify the solution graphically. So we're going to verify that we got those answers with a graph. So first, let me rewrite this statement here. 10 sine x minus 0.2 equals a -3. All right, tell me, guys, what do I do first? Not everyone at the same time. Oh, man.
Sorry,
Guys,
could you repeat the question?
yeah, I'm trying to solve for x, guys. So the first thing I got to do is divide by 10. What if Ms. McLaren was here observing me, guys? I would get like a really bad score because no one's helping me out here. Divide by 10, both sides. So then we're going to get sine of x minus 0.2 equals, and you could write it as a fraction, but I already have this in decimal. So it's probably best to just have one form. So I'm going to write this as negative 0.3. All right, now what do? I'm trying to solve for x, guys.
Arc sine.
Perfect, arc sine. So I'm going to write x minus 0.2 equals arc sine of negative 0.3 plus 2 pi n. And since I'm going at it already, guys, I'm going to put a subscript down here and I'm going to make it a 1. So write x of 1 minus 0.2 equals arc sine minus arc sine of 0.3 plus 2 pi n. I'm going to change my color to blue and I'm going to write my second equation in blue. So I'm doing both at the same time. So here we go. I'm doing the same thing again, guys. X of 2 minus 0.2 equals, now I'm not going to write arc sine of negative 0.3 again. Remember, I'm doing the second equation. So if I'm doing the second equation, here's the first one. I just did this part right here. So what am I going to write first now?
Pi minus, and then what we have? Okay.
Yeah, you just had it perfect. It's pi minus arc sine of negative 0.3 plus 2 pi n. See? I'm going to jump back to my equation in red. All I'm going to do is move the 0.2, x1 equals, and I like to put the 0.2 here in the front. That way no one gets confused with the then over there. 0.2 plus arc sine of negative 0.3 plus 2 pi n. And we'll figure out what that general equation is in a little bit with Desmos. I'm going to jump back to x2, the blue one, and I'm going to write x2 equals 0.2 plus pi minus arc sine. All I'm doing is just basic algebra, guys. Order of operations. Mumbo jumbo, nothing crazy. I take my calculator and I'm going to find out what those numbers are, guys. So here we go. Let's share and let's see if we can do this together. I'm going to go to my Desmos. So here's my Desmos. And let's see, okay, I'm in degree mode. Nope, I'm in radian mode. So click radian. So there it is, radian. And I'm going to go to, what was it, the first one? Arc sine of, no, wait, did I have 2 or something or no? I already forgot it. Let me go back. Yep, 0.2 plus arc sine. So I'm doing the one in red. So here we go. So let me clear that out. 0.2 plus arc sine. And then inside of arc sine is negative 0.3, right? So there it is. Write that number down. Put negative, you know what? I'm going to put an A on this because I might need it later. So what do I mean by that? I'm going to call it A equals that. So put negative 0.10469 plus 2 pi n. So I think I can remember that. So let's see. Okay, I already forgot it. Hook me up, guys. Negative 0.10469 plus 2 pi n. That's what you call your general equation. Now I'm going to go to this one, guys. X2 equals. If you recognize that this is just A right here, you can call that 0.2. Oh, that's not A. Never mind. Oh, wait. No, that's not A. Don't call it A. I'm going to call it B or something. All right, 0.2 plus pi minus arc sine. So here we go. Let me do that. So go back. 0.2. I already forgot. Yeah, when I don't get much sleep, my memory, short-term memory is bad. Let's see, 0.2 plus pi minus arc sine. And I realized that I could have just typed it in there, but I wanted to use a different letter just in case if I have to recall stuff. Negative 0.3, close it. So I think that's correct. We're gonna find out right now. 3.64628 or 9 if you round it. 64628. I think I got it. All right, let's go back to this guy. So 3.64628. Did I get it right? Plus 2 pi n. So there it is. Those are my general solutions. I want all the answers between 0 and 4 pi. If you don't know what 4 pi is, just type 4 times pi, and I think it's 12.566. So let's see. The first one I hit, I'm going to use a neutral color, guys. I'm going to use black. So I'm going to write x equals. So that one is not in the domain. So do not write that negative 0.10. That 3.64628, though, is in the domain. So that's the first one, 3.64628. The next one is going to come, this one comes from x2. The next one's going to come from x1. So you take the negative 0.10469 and add 2 pi. So let me go to my Desmos again. And I'm going to just do just that. Now look, remember, I have it saved as A. So I can just type in A, and look, there it is. And then I'm just going to put plus 2 pi. So there's another answer, 6.17849. So 6.17849. 6.17849. Did I get them right? Okay. Next one is going to come from x2. So I'm going to take the 3.64628 and I'm going to add 2 pi to it. So I'm going to go back. And here we go, Desmos. And I'm just going to go, I'm going to push enter on that. I'm just going to go B, because remember I had it saved as B there. So B plus 2 pi. And there it is, 9.9294. So let's go to 9.9294, comma. And then I think I'm going to have one more. If I take that 6.17849 and I add 2 pi, I think I'm still inside between 0 and 12.566. So let's go and do that. So let's see. This, which one am I going to take? The 6.17? So I'm just going to come up here to this A plus 2 pi, and I'm just going to add another 2 pi plus 2 pi. 12.4616. So share, I'm going to write 12.4616. And I think that's it, guys, because if I take the 9.9294 and I add 2 pi, I will be outside the 4 pi, because that's like 3.64628 plus 4 pi, and the 3 is already positive. So that's it. Those are my 4 answers, and I'm going to check it graphically. So it's easy to check it graphically, guys. Just type this one into Y1 and type that into Y2 in your Desmos. So let's see. I'm going to go back to Desmos again, and I'm going to click back. I'm going to push graphing calculator. And let's see if I remember the equation here. Y equals, was it 10 sine? Okay, 10 sine x 0.2, got it. And then on the next column, I'm going to put y equals -3. All right, and then I just click on the little wrench here, and I just go 0, and then I just push 4 pi on that one, 4 pi. And let's see, since I just care about -3, if you want to see the whole graph, you can go like -12 to, you can almost see it, I guess, to 12. And there it is, guys. And check it out. I have 1, 2, 3, 4 intersections. So I have 4 numbers. Let's see what those 4 numbers are. You just click with a mouse. And do I have 3.646 as one of them? All right, let's go to the next one. Do I have 6.178? 9.929? And finally, 12.462. There you go. Yay, we did it, guys. We did it. How do we feel? Guys? Okay, here we go. So now this one says example 2. This one's in degrees. So I'm going to change my mode to degree mode. And it says solve the equation 4 tan x equals -5 for the first 3 positive values of x. Okay, so 4 tan of x equals -5. I'm trying to solve for x, So they're being nice to me, nothing crazy. First thing I do is just divide by what? Yeah, just divide by 4. So tan x equals a negative 5/4. And then to get x by itself, I just do what?
Arctan.
Perfect. That's it. That's all you're doing. Arctan of negative 5/4 plus, don't write plus 2 pi n, don't, because it's not plus 2 pi. It's 1 pi, but we're in degree mode, so it's not even pi's. It's what?
180 degrees.
Perfect. It's a 180 degree one. So I'm going to put plus 180 in. This is what you call your general equation. I put the degree symbol there. If you don't put the degree symbol, that's fine. But make sure that you recognize that you're getting values that are degrees. So here we go. X equals, I'm going to go to Desmos, and I'm going to make sure that I'm in degree mode. So here we go. Desmos. And I just noticed that I say the words, here we go, like way too much. So I'm going to see if I can stop with that. All right, graphing. No, I don't need a graphing calculator. I need a scientific calculator. I mean, a graphing calculator is fine, but so here it is, degree mode. So I'm just going to go to function, arctan, and it was negative 5/4, if I remember correctly. Or no, that was okay. So 5/4. So there it is, negative 51.340 degrees. So write that down somewhere. And now I'm just going to add 180 to it. So I guess first let me write my general equation. So here's my general equation, guys. So hopefully I remember that number. Negative 51 point what? 340. Put a degree symbol, guys, because that is a degree. Now they wanted the first 3 positive values. So you're not going to write the negative 51 as an answer. So here are my answers. Add 180 to that answer. So I'm just going to go back to my calculator. And I'm just going to push, let me see, if I call this A, which I probably should have done that earlier, A equals that. So now that it says A equals that, I can just type A plus, where are you? Plus 180. So there's another answer. So write 128.659. I guess you could also say 700, but 6598 if you want to put another digit. And I'm going to add another 180. Right, 308.6598. And in a little bit, you hook me up with the numbers, miss. And they wanted the first 3 positives, so I'm going to add another 180. 488.6598. These are all degrees. All right, I'm going to come back and I'm going to write my solutions, guys. So let me rewrite this a little further left here. X equals, what were my answers? 128.6598 degree, comma, 308. And one more. There it is, guys. How are we feeling so far, guys?
Good.
Okay, good. The good life. Math life is the good life, guys. So is science life. Math and science really just go 1 and 1 together. Biology might be the oddball, but biology is also a very fun class, so you should love all of them. Sorry, I'm getting a text message from Ms. Corpus. I think I haven't taken attendance, so yeah, I better take attendance in a little bit. Let me finish this up first because we already got started with math life. In degrees, solve algebraically. And I put this one in there for a reason, guys, because I noticed that we were having issues with the negative domains. So this, I think you guys are pretty, like, I think you guys can do this pretty easily. So notice what it says, sine squared minus sine x minus 2. And I see the chat, hold on. Oh, yeah, there is math life in bio. There's a lot of stats in there. Chi-squared, the chi-squared exam, the test, standard deviation, stuff like that. So when you guys were in algebra 2, or algebra 1 for that matter, you guys would have these equations all the time. X squared minus x minus 2 equals 0. See? And then you ask yourself, is this factorable? And hopefully by now, these are automatic, and you're like, yeah, that's factorable. And you can just go x minus 2, x plus 1, and you can get your solutions really quick because you want the product to equal 0. So that means x equals 2 or x equals negative 1, because negative 2 plus 2 is 0, and 0 times anything is 0. Or negative 1 plus 1 is 0, and 0 times anything is 0. So those would be your two solutions if you were in Algebra 2. But we're not in Algebra 2 right now. We're in Precal, and we're doing the same logic. I'm going to factor this out, guys. So when I factor that out, here's how it's going to look. It's the same factors, but instead of an x, I'm going to write sine x. So sine x minus 2, sine x plus 1 equals 0. And I know some of you guys, maybe you were absent anytime. So here's a side note, not a big side note. Sine squared x means that it's sine x that is being squared. The reason that you put the square after the n is because we understand that it's sine that's being squared. If you were to put the square after the x, then it's the x that is being squared. Does that make sense to everyone? So like what I'm trying to say is this. That does not mean that. If the square is after the n, that means that it's sine that is being squared. If you want to square the x, then you do it like this. All right, so now we're back at this, guys. So I have this expression here, sine x minus 2 and sine x plus 1. So now all you're going to do is just solve. Well, so the only way that this will be 0 is if sine x equals 2. That's not possible. And I'll tell you why it's not possible in a little bit, guys. And sine x plus 1, that is 0 whenever sine x is a negative 1. And yes, you could do the formulas that we just learned a little while ago. But if it's a perfect argument, if it's a perfect coordinate like this one, and the unit circle, sine's only negative 1 in one location. The only location where sine is negative 1 is down here where this green dot is. That's the only location, guys. If we were in degree mode, we would call this 90 degrees, 180 degrees, 270 degrees. But then notice that 270 has a parenthesis. So is 270 an answer? No. We observe that the domain starts at negative 90. Where is negative 90? Well, if you start at the positive horizontal axis, negative 90 is this guy. So the only solution on this one is negative 90 degrees. Isn't that cool? Now, by the way, this is not possible because sine x is always between negative 1 and 1. The smallest that sine x can be on the unit circle is a negative 1. The biggest that sine x can be on the unit circle is a 1. If you don't like that visual, let me draw a different graph for you guys. I'm drawing y equals sine x, and here it is. Not the best graph, I know. Well, it got worse as I went to the left. The biggest sine x can be is a 1. The smallest sine x can be is a negative 1. If I were to type sine x on the y1 and 2 on the y2, well, 2 is way up here somewhere. Let me put like 2 up here. And you would just have this line. And you can see they never touch. So that one's never going to be possible, guys. So there you go. I covered everyone. I covered the visual learners. I covered the algebraic people that want to see formulas. I covered every single possible aspect that I can think of. If you have more ideas that you can let me know, guys, let me know. You see, I've been covering everything, or at least trying to cover everyone so everyone can learn. I put a lot of thought into these notes, guys. All right, I think we're good, unless you guys tell me we're not good. Are we good, guys? Uh-oh, did they fall asleep?
We're good.
Okay, no one's asleep, right?
No, I was just writing down the little diagram.
All right, guys, take a 10-second break. I need your A game on this one, so get up so you can wake up a little bit. So if you're sitting down, if you're lying down in your bed, wherever you're at, just get up. So let's get up, miss. So, and then maybe punch the air a little bit. You know, stretch, maybe do a kick. Those noises you hear is actually me kicking, guys. So we're trying to wake up here. All right, I feel good. I hope you feel good. Do you guys feel better now? Ms. Alcocer, you feel better? All right, let's get back at it. There's a reason why I woke you guys up on this one. So let's say for a job interview, they ask you to solve the following problem. And then for you future engineers, this is not uncommon, not necessarily this problem, but it's not uncommon that they ask you a question of whatever you're majoring in. It might be a logic problem. Maybe they'll ask you to, I don't know if you guys know that's an AND gate and an OR gate, and maybe they want you to produce a certain type of output. And they, well, okay, maybe I'm getting too advanced here, but it's not uncommon for them to give you a STEM related question because that's what you're going into. You're an engineer. All right. So here's what I want you guys to notice here on this one. If you were to do this in algebra, like this is similar from your algebra days as 4x squared minus 2x minus 3 equals 0. And the very first thing you're going to ask yourself is, can I solve this question? Can I factor this question? Because of course we can solve it, right? But can I factor this question? Well, I don't know. Let's see. 4 times negative 3, that's a negative 12x squared. Now, numbers that give you negative 12x squared but add up to a negative 2, let's see, negative 6 and 2, nope. Negative 4 and 3, nope. And the difference between those are larger than 2, so even if I reverse them, it's not going to work. 12 and 1, negative, nope. Nope, not factorable. You cannot factor this one. So how will we solve this when you were in Algebra 2 without graphing it? I mean, yes, you can graph it and see where it intersects the x-axis. Without graphing it or completing the square, what is another tool that you have to solve for that? It starts with the letter Q. Yeah, say it. Say it loud and proud. Second letter U. Yeah, a quadratic formula. Do you remember the quadratic formula, guys? Are you guys there?
Yes, we remember it.
What is it?
Aren't you writing it?
Yeah.
I remember it. I just don't remember it exactly.
If you want to sing that song, I don't remember what song someone made. Negative b plus or minus square root of b squared minus 4ac, or I don't know, all over 2a, or it doesn't even rhyme. Like, how does? All right. Anyways, this is the quadratic formula, guys. There it is. No big deal. And you can use a quadratic formula for anything that looks like a quadratic form. It doesn't have to necessarily be a quadratic. Chavez, what are you saying? You're not making any sense. What I'm saying is this. It has to look like this, guys. And I don't have to have an x. It can be anything. I could write this: a happy face squared plus b times happy face plus c equals 0. Oh, let's solve for happy face. All right. Happy face is going to be equal to negative b plus minus square root b squared minus 4ac all over 2a. So it doesn't have to be an x, guys. It just has to look like a quadratic. And that up there definitely looks like a quadratic, guys. So here we go. I'm going to write 4, and I'm going to write it in parentheses so you guys can see that it's in a quadratic form. Minus 2 minus 3 equals 0. It's in quadratic form. A is 4. B is negative 2. C is negative 3. I'm going to insert. What am I going to insert? I'm going to insert that into the quadratic equation. So I'm going to say sine x, because that's what I'm solving for. See, wherever you have a happy face, you have happy face equals that. So in this one, I was solving for x, so x equals that. So I'm going to write sine x equals, and I'm going to write my quadratic equation. Opposite of b, 2, plus minus square root, negative 2 squared. I've never really liked putting negatives when I'm squaring something like that, but to be technically correct, I'm going to continue it. 4ac all over 2 times. I'm going to type what I just wrote there on Desmos. And I'm going to put one for the positive and one for the negative. So let's see. So I'm going to go to Desmos, and you guys help me out. What is what? So here it is, Desmos. I'm going to clear everything. Okay, here we go. I'm going to put a equals just in case I need a, but don't worry, I got you, miss. Let's see, I need a fraction. So on the top, I write 2, and instead of plus minus, I can only do 1 at the moment. So I'm going to put plus. 2 plus square root -2 squared minus 4 times 4 negative what? 3. There it is. And there's one answer. And notice that sin x can't be, we'll talk about it right now. So let me go. So I have sin x equals 1 point, and I already forgot. I didn't look at it. I just saw that 1.15138. 388. Because I'm gonna stop there. 151388. Okay. 1.158388. Oh man. 15183. Yeah, that's what I said. No, I'm kidding. I didn't say that. All right. So there it is. There's one of them. By the way, is this one possible? No, not possible. For the reason we just talked about over here. For the same reason we just talked about over here, guys. Sin x has to be between -1 and 1. So that one's not possible. So now I'm going to go back to Desmos. And instead of plus, guess what I'm going to do? Minus. So here's my Desmos, and I'm going to change that plus. I'm going to push minus, and then boom. There it is. That one is definitely possible, 100%. -0.651388. So I'm going to put that in there. Oh, let's see if I remembered. -0.651388. Only because the pattern was similar on this one. There it is. I was about to write some shenanigans. Good thing I didn't. Are we okay right now, guys? Now, I'm just going to solve for this. And I guess you could solve it by graphing, but then that defeats the purpose. You could have just immediately graphed it, right, and see what the answers were. All right, let's solve it, guys. Inverse, inverse. So I'm going to have two solutions. X equals, here's my first equation, arc sine of -0.651388 plus 2 pi n. That's equation 1, so I'm going to put x of 1. And here's equation 2 over here in blue. Equation 2. Pi minus, because I think we're in radians, arc sine of -0.651388. Always use the exact what you have in your calculator, the register in the calculator. Use the memory, take advantage of that. All right, let's see what that is, guys. From x1, here's my general equation. I'm going to come back to Desmos, and I'm going to find out. So here it is. I have it as A. So A is all that shenanigans there. So I'm going to put arc sine of A. No, I don't want degrees, radians. There we go. So there it is. -0.7094. -0.7094. So I think I can remember that. -0.7094 plus 2 pi. And I'm going to save that. I like to go down the alphabet. I'm going to save that 0.7094 as B. So let me go down to Desmos. And I'm going to put B equals. B equals. Because I might have to use it in a little bit. All right, let me get the next one, guys. So I'm going to put C then for the next one. C equals pi minus arc sine of A. That's the one in blue there. And I got 3.851. And then the next two digits are 0, 0. So you can just stop at 851. 3.851. So I'm going to write that for the one in blue. Here's my general equation. 3.851 plus 2 pi n. We're so close. We need to get our answers now. I'm looking between 0 and 2 pi. So let me use black. So my first answer is going to be the 3.851. So x equals 3.851, comma. And then my next answer is going to be this negative value plus 2 pi. So I believe I saved that as A. Or no, I think I saved it as B. Yeah, it was B. So I'm gonna write B plus 2 pi. Plus 2 pi. There it is, guys. 5.573 or 574. 57377. I'm gonna put all those digits. 5.57377. 5.57377. Let's see. I'm gonna write it here for good notes. This one came from X2. And look, I'm even color coding it for you guys. That one came from X1. Notes color coded and stuff and cool. All right. Let's see. These are my answers. Let's see if we're correct. We're just gonna verify with a graphing calculator. I'm gonna type that into Y2, onto Y1, and I'm gonna see where I cross the x-axis. So let's see. Go to Desmos, and we're almost done, guys. We're almost done. Back screen, graphing calculator, and I'm gonna type in y equals, and then 4 open parenthesis function sine x close close, put a square on it, 4 sine squared, and then what did I have? The original equation? 4 sine squared x. You know what I'm talking about? Minus 2 sine x, yeah. Minus 2 sine x. Minus 3. Look at all the, look at this awesome wave, guys. Cool wave. You know, your cell phones work with waves. They're all inputs. They're just all electronic signals, guys. Let's see. I'm looking between 0 and what? So in 2 pi. Cool wave, sir. I mean, I'm not talking to anyone in particular. I'm just saying. All right. Here are my 2 answers. Let's see if they're correct. Click here. Did I get 3.851 as one? And then click on the other 0. 5.574. There you go, guys. Awesome. All right, guys. Let's all come back. So let's